Hello everyone, welcome to Jason Tech. I'm Jason. A high-level question often asked by data center customers was, what chips did you use? I will release 3 videos to talk about this topic with you, so as to improve your horizons and chat skills. My channel shares high-level tech topics related to data centers, talking you to improve your horizons and skills. Follow me, turn on the little bell, and don't miss any high-level videos. The mainstream network equipment manufacturers in the industry must be familiar to everyone. Most of the products of these mainstream manufacturers use Broadcom forwarding chips. So today, let's talk about Broadcom's data center network equipment forwarding chips. Broadcom's data center forwarding chips mainly have 3 series, which are very well known. They are Trident, Tomahawk, and Jericho. Trident, referred to as TD, such as TD3, is Trident 3. Tomahawk, referred to as TH, such as Tier 2, Tier 3, is the 2nd generation and 3rd generation Tomahawk. There is another series which is Jericho, referred to as J, such as J, J+, J2, J2, C+, etc. The first and second types of the chips just mentioned, namely Trident and Tomahawk, belongs to Strata XGS, referred to as XGS. Jericho belongs to Strata DNX, also called it Dune. Strata DNX series is Broadcom in 2009. The acquired is a really cheap company. This Dune is the company's main chip product. As long as you know, there are 2 major catalogs and 3 major series. Different series of the chips have different positioning. The positioning of Tomahawk is mainly the position of the interconnected span of the fabric, connecting multi-leafs. It does not emphasize functions and only seeks high-speed forwarding. And at present, most of the devices are box-type devices, so it was so-called single-chip box span devices. Generally, there are high-density 100 gig ports, such as 64 100 gig ports, 128 100 gig ports, etc. Trident is mainly positioned at the leaf position of the fabric for server access. Pursue rich data center functions and features such as VLAN Layer 2 and Layer 3 gateway functions. The positioning of the Jericho series is mainly for modular, or what we call the chassis switches, featuring a large cache. At present, Jericho chips devices in mainstream data centers are generally placed in DCI interconnection scenarios to replace routers. In this video, we will talk about the Trident series in detail. This is the standard span leaf network. Generally, on leaf devices, the forwarding chip is Trident, referred to as TD. Up to now, Trident has gone through 4 generations from TD to TD4. From single chip 640 Gbps to TD4 single chip 8.0 Tbps. Whoa, that's amazing. Single chip bandwidth has increased by 12.5 times in 10 years, greatly improving the network access rate. Next, let's take a look at the model, speed, port form, and functional characteristics of the Trident series chips one by one. Let's take a look at the models first. Broadcom's models are very easy to remember. And the chips starting with BCM56 generally refer to the Trident series. So it is important to remember that the first generation chip is 56840. The 2nd generation, 3rd generation, is standard plus 10 until 880. In different chip series, there will be high and low-grade chips such as Trident 3, referred to as TD3, which can be divided into X7 and X5. A lower grade, that is TD3 X5 56770. What use is this to us? During our communication to high-level customers, when someone proposed TD3, you can ask whether it is a 56870 or 56770 chip. that is TD3, X7 or X5, and you can easily know whether they used a higher performance 3.2T chip or only 2.0T chip. Next, let's take a look at speed, part shape, and functional characteristics. The first generation Trident with a maximum weight of 640 Gbps is more suitable for 48-port 10 GB and 4-port 40 GB data center access products. Based on simple calculations, is 48-port 10 GB equal to 48 multiplied 10 GB equal to 480 GB plus 4-port 40 GB is equal to 160 GB. A total of this is equal to 640 Gbps. This is just enough for the full port line speed forwarding of the chip. So in the early years, the form of 10 gigabit switches was 48 10 gigabit ports plus 4 40 gig interfaces. When the first generation of the chips came out, I remember the era of Cisco Fabric and Juniper Q Fabric. At that time, protocols such as the Trio and SPB famous. The absolute of the storage is also a very important feature. Therefore, at the level of functional characteristics of the hardware chip, it provides relevant SDK drivers for the mainstream characteristics of the data centers at that time. Soon, the second generation of the Trident TD2 chip came out. The bandwidth of a single chip is doubled compared with the first generation, which is 1.28T bps. In this way, a maximum of 32 40 gig interfaces can be provided, which can be used as the access of 40 gig servers or the convergence equivalent of small fabrics. Of course, there is another important point, that is at that time, VXLAN gradually became mainstream from being proposed, forcing the TD2 chip to support VXLAN. Later, with the optimization of the components, TD2 Plus came out to replace TD2. The most important reason is energy consumption. Compared with TD2, energy consumption can be reduced by 30%. 300 access switches using TD2 Plus, each year it can reduce 100,000 kWh per year. Therefore, the mainstream 10 gig switches use TD2 Plus for access, and the model is 48 10 gig ports plus 6 40 gig uplink ports. At that time, using the built-in hardware chip VXLAN function SDK to develop VXLAN function for fabric networking. With the large-scale landing of cloud data centers, network cards have also been upgraded from 10 gig to 25 gig network cards. At that time, switches are required to support 25 gig network card access capabilities. Thus, TD3 has to be mentioned in the chip selection of access switches. TD3 X5 2.0 Tbps of the company can do up to 48 25 gig. That is 48 multiplied 25 equals to 1200 gig. Plus 8 100 gig means 800 products. This is 2.0 Tbps. This has also become the port type of the 25 access switch. That is 48 25 gig interfaces and 8 100 gig uplink interfaces. At that time, TD3 also has a high-level X7. That is, a single chip can achieve 3.2 Tbps. In this way, the port type can be more abundant, such as a 32-port 100 gig type or 128-port 25 gig type. In addition, in terms of functional characteristics, it also increased various protocols such as GNAF and NSH have been added. In addition, at the operation and maintenance level, various chip-level operation and maintenance features such as INT, TCB, and MOD have been added. If you are interested in this, you can leave a message and I can make a special video to talk to you about operation and maintenance of chip-level features. In the past 1 and 2 years, The latest chip is none other than TD4. The single chip is up to 8.0 Tbps, mainly for 100 gig high-density server access. The mainstream model is 48-port 100 gig plus 8 400 gig ports, which is exactly 8000 Gbps or 8.0 Tbps. Let's think about the concept. Many customers are still using 48-port 10 gig for server access and uplink 100 gig. Now, 48 100 gig type is used for server access and uplink is 400 G. What? In the past few years, the tenfold increase in access capabilities is too scary. In addition, some AI customers need 200 gig server access, and TD4 can also do it. TD4 can up to 24 ports of 200 gig for server access and 8 ports for 400 gig for uplink, which can meet the computing support of 200 gig server access. The new generation of TD4 chip also has the programmable capability, which means maybe you have heard about the Barefoot, right? The Barefoot programmable chip is just like the same, which can do DDOS, LB, NAT on the switches. In the past, there were many features to be deployed on the routers or firewalls, and now they are expected to be implemented on switches. Alright, that's all for today's video. Let's leave an assignment to see how well you have mastered it. The first one is, what are the three major series of Broadcom data center chips? The second one, the Broadcom Trident series. For example, what models are there? What generations of chips are used by which switches? What is the port type? And the chip determines the functional characteristics. So what would you say when comparing 10 gig, 25 gig, and 100 gig switches? I will put the answer in the introduction. Please leave a message if you have any questions. In the next video, we will focus on the Tomahawk series chips, and see you next time.